Hey there, welcome back. So in the previous video, we have talked about what is PyTorch and how it came into existence, what the creators of PyTorch and so on. And while talking about PyTorch, we also came across the name of another deep learning library, which is TensorFlow. Now, oftentimes what happens is whenever we talk about PyTorch, we end up talking about TensorFlow, since TensorFlow as of right now, and I'm recording this video, the most popular deep learning library in the world, right? So in this video, what we are going to do is we'll see some of the key similarities and differences between TensorFlow and PyTorch. So TensorFlow is just another deep learning library which provides you all the tools and everything that you need in order to create a neural network. So TensorFlow also provides you tensors and the different functions and all these things to build neural networks. And this is again a definition of TensorFlow, which I've again copy pasted from tensorflow.org. And if you want to know more about TensorFlow, you can even go to this website and browse through it. It's a great website and contains a lot of content for developers to learn. Now coming to the different similarities and differences between TensorFlow and PyTorch. So TensorFlow was developed by the Google Brain team, whereas PyTorch was developed by the Facebook AI team. Now both of these libraries, TensorFlow and PyTorch, they work on tensors. So whatever operations or computations you are going to do in case of training neural networks, you are going to do all of that on top of tensors. You can't use any other data types like NumPy ND arrays or list or anything like that, right? You have to do everything on top of tensors. Now these libraries also have support for CUDA, so that means you can create tensors and train neural networks on top of GPUs. So that is a great feature which is available in both of these libraries. Now the key difference between TensorFlow and PyTorch is that TensorFlow works with a static computation graph, whereas PyTorch works with a dynamic computation graph. Now, if you recall, what is a computation graph? So a computation graph is something that contains some nodes and edges, and it defines the flow of execution, right? How data passes through the neural networks, like from one node to another through the different edges which are there, right? So that computation graph is static in case of TensorFlow, which means that once you define the computation graph, you can't change it, right? Throughout the training process of the neural network and everything, that computation graph will remain as it is. But in case of PyTorch, you can change it because of its dynamic nature. So maybe for the first 5 iterations of training neural network, you have some computation graph and then you dynamically change the computation graph. So that is something which is possible in case of PyTorch, not in case of TensorFlow. Again, so for TensorFlow, as it has a static computation graph, it must be defined first before it can be run. But it's not the case of PyTorch. You basically create and run it. There is no step like between definition and running, right? Now the neural networks that you create in TensorFlow, these need to be compiled. You can't just directly train the neural networks after defining them. But in case of PyTorch, you can do that. You just create a class, which might just extend from the torch.nn.module, and you just define a neural network inside that class, and you create an object of that class, and you just directly start training. That's it. But in case of TensorFlow, you can't do that. You first have to compile, then you have a compiled network, and then that network you can train. Now again, in case of training, you can't directly train also in TensorFlow. You have to train it inside tf.session. So you need to create a variable of tf.session, and within that session you can train your neural networks. So what tf.session does is it just creates another session and it separates it from the default Python session which is available. And in case of PyTorch, as it's tightly integrated with Python, you don't have to do anything like that. You can directly train your neural networks. Now debugging is also something which has been discussed previously. So debugging in TensorFlow is a bit difficult since you have to have knowledge about the tf-debug library which is there with TensorFlow. And in case of PyTorch, as it's again tightly integrated with Python, so you can use the native Python debugging which is available. Now coming to visualizations, now this is one place where TensorFlow just kills PyTorch because it has TensorBoard, and TensorBoard is superbly feature rich. It provides a lot of different ways in which you can visualize your neural networks. But in case of PyTorch, you don't have anything similar to TensorBoard. Rather, you just have Torch Vision, Matplotlib, Seaborn, and all these things. Like all these open source libraries are available, and you have to use them somehow in order to visualize your neural network. But there's one thing to just know here that I've heard that TensorBoard can also work for PyTorch, and they have added that support for that, and but I'm not exactly sure about it when I'm recording this video. But if it's available, then I will create a video about it, and I will also put it in the channel, and the link to that video will be there in the description. Now coming to deployment of trained TensorFlow models. So you have to deploy it using TF serving, and in case of PyTorch you don't have anything like that, so you basically have to create your own Flask API, a simple Flask REST API would do the job, and there you will just create an inference endpoint, and there you will host your neural network model, right? So this is pretty much how you deploy the PyTorch models. Now, like after all these things, so what are the key differences between TensorFlow and PyTorch? So the key difference is that the static and dynamic nature, right? So TensorFlow by default provides you a static computation graph, whereas PyTorch by default provides you a dynamic computation graph. Now there are differences, okay? Like there are different scenarios in which a static and a dynamic computation graph performs better. So a dynamic computation graph and like the dynamic nature, you know, of PyTorch. So this is something which is great when you are doing rapid prototyping. So you want to create, you want to quickly create a neural network and test out something, then PyTorch is handy in case of that, because you don't have to go through all these different steps like defining a neural network first, then compiling it, then creating the different placeholders, which you have to do in case of TensorFlow. Even like, in case of TensorFlow, you can't directly store the data in some variables and, pass those variables while training. You just can't do that. You have to create placeholders for variables inside your computation graph, right? So these things you won't have to do in PyTorch. You can, and because of these reasons, PyTorch is great for rapid prototyping. So you basically define your tensors, you store data in your tensors, and then you pass the tensors while training. So PyTorch is great when you have to do rapid prototyping. Now TensorFlow, with all its static computation graph and placeholders and all these things, it's actually great when you are doing production deployment, because static computation graphs and this entire setup that TensorFlow has with placeholders and that static computation graphs, this is great in terms of performance compared to a dynamic computation graph setup of PyTorch. So TensorFlow is often preferred in case of production deployments and all these things, right? Compared to PyTorch. Now there's also one thing that you should remember, that it can't be possible that PyTorch and TensorFlow, like Facebook developed PyTorch, like Google developed TensorFlow, and if they already know about it, like they won't really create a deep learning framework which can only be used in production deployment or rapid prototyping or something like that, right? They want the deep learning library to be useful in everything, and because of that reason, TensorFlow now has an eager execution mode for dynamic computation graphs. So if you want to build your neural network model similar to PyTorch in TensorFlow, you can just use the eager execution mode. And this is something which TensorFlow has learned from PyTorch. Whereas you talk about PyTorch, it has also added now the support for static computation graphs, right? So you can even use PyTorch for production deployments. But still now, the default mode of both of these libraries remain the same. So the default mode of TensorFlow is of a static computation graph, whereas the default mode of PyTorch supports a dynamic computation graph. So this is pretty much it. So these are basically all the similarities and differences between TensorFlow and PyTorch. So yeah, that's it for this video, and in the next video, let's start by setting up the environment in which we are going to work on, because starting the next section onwards, we'll have all the hands-on sessions on PyTorch and tensors and all these things. So that's it, and I will see you in the next one.